All right. Hi, everyone. It's live app review episode 14, maybe, hopefully. And I'm with Vadim and Dorian from the Near DevRel team. Say hi.
Hello.
Oh. All right. So today, the last two episodes, we were working on a fungible token launcher. So kind of like a kitchen sink example of everything you can do with a standard near fungible token following the NEP 141 standard. And there's an issue of sort of, each account needs to kind of cover their storage. So there's a storage management standard. I think it's NEP 145 or 146 or something. But you can check out those episodes. I think it's episode 12 and 13 for those. So today we're starting the NFT launcher. So we're basically building a standard, a near standard NFT launcher example where we're going to have a sample app that you can play around with, but we haven't done that yet. We're going to have a server API where you can mint tokens. I think Vadim has some updates on that, but we haven't kind of made it official yet, but we're working on all of this. And what I have some application tests that we can run through. So as a precursor to building the app, I've got some of these application tests for the NFT standard. So I'm going to share my screen now. So you should see my screen. So just a quick walkthrough of the contract itself first. So let's make my screen a little bigger, hide the console there. Yeah, what else do we need from the contract? Yeah, we'll open up this mint file too. Okay, so only 4 files here in the NFT standard so far. We call this NFT, it's sort of got a code name NFT simple for now. So it's a simple non-fungible token contract. So you can create many non-fungible tokens from this one contract. You can have the owners transfer the tokens to each other, so they can just transfer directly from one account to another. You can do what's called a transfer call. So what a transfer call is when you want to transfer a non-fungible token to another smart contract, they can implement the, well, I'll just show it here while I'm talking about it. They can implement the, so you can basically do a transfer call, and then another, a non-fungible token receiver contract can basically implement a callback that can receive a non-fungible token. So for example, if you have a game and you need to have a pass to enter the game, you would have to send, let's say you got airdropped these non-fungible tokens, so they're in your Near account. You would do a transfer call, and you would send the non-fungible token to the smart contract, and then the smart contract would basically be a non-fungible token receiver, and the callback would get called, and then this smart contract could, for example, let you into the game, or take your pass and mint you a like an actual ticket or something. So not quite sure what we're going to do with this, but obviously you want to be able to send non-fungible tokens to smart contracts to do all sorts of things with your projects. So that's that. So basic transfers, transfers to smart contracts, and then let's look at these 3 here. So we worked on these a couple of days ago, Eugene and myself. And so we have NFT approve account ID, revoke account ID, and revoke all. So what does this let us do? Well, one of the best things, or not the best thing, but a popular thing to do with a non-fungible token is to sell it. So you have to approve a marketplace to sell a token on your behalf. So in order to do that, you have to allow other near accounts to transfer the token on your behalf. So we'll see an example of that today. So that's really the standard for the NFT stuff. There is a file called internal. What this does is this just keeps a lot of the complex kind of things that are fairly standard. Like, think of these as sort of like internal kind of private helper methods. You don't need to worry about them. So basically it just actually is the code that is responsible for executing the transfer. So if you want to know like what's going on, under the hood, you look at this internal file. Mint is obviously like an important function. So Eugene actually had it set up to mint only to the owner of the contract. So it was restricted. It was restricted to the owner. I think that was just something, I'm not sure if that was intentional or not. So I think it may have been an oversight that he had a thing here, helper. So again, one of these internal helpers, he had only owner. So, so basically if that's there, then only the owner of the non-fungible token contract can be the minter. And that's good in some senses. So for example, if I create a non-fungible token contract for my video game, I do want the minting to be only for the owner. But in this case, it's like a generic NFT contract. So it's like a community NFT contract. So it's like, everyone come on and, mint your tokens. And the contract doesn't run out of storage, because what we do is we check the initial storage here. And then what we do is we measure the new token size in bytes, and we make sure that the user has attached enough payable by calling deposit. Well, we refund any extra that they have. So they must have attached, there's no fee for minting, but they must have attached enough to cover the new token size in bytes. So we take all of the near that we need to cover the storage for the new token that the user wants to create, and then we refund the rest. So we're letting, it's very open right now. It's very generic, and we don't have any custom business logic or anything. But as I mentioned before, like if you are a game or whatever, and you only want your owner to mint, you can do that as well. Like, so all of this stuff is very flexible. So I'm not kind of trying to, in these examples of like a fungible token launcher or the non-fungible token launcher, we're not trying to prescribe like what you should do with these tokens. You can obviously layer in any logic that you want that would either restrict or like extend the token's capabilities. So yeah, for
But could you tell me, please? Yeah, I have a question. So you are reviewing the contract from repo core contracts, right? From that branch of NFT simple. And this is the most current, the most recent version of NFT contract, right? Because I remember we had a lot of examples with different NFT contracts. Are all of them outdated now?
That is a great question. So let's go look at, I think I have it here. So that's a great question, Vadim. So here is the contract that we're looking at, but locally. As you can see, Eugene made an update yesterday. There's also examples.near.org. There's non-fungible tokens here in these examples. And this is using a older standard that we came up with for examples. So basically, it was even before the mainnet was launched. So it was a long time ago. So you see it's relatively outdated here. The issue, the main issue with this example, thanks for asking, Vadim. The main issue with the example is that if you look at the contract, the Rust contract, it's just a single file, and there's no There's grant access, revoke access. So you'll see that you're adding a single account that can basically transfer tokens. So it's not adding accounts on a per token basis. There's no accounting for storage. So one of the issues with letting a user come to your smart contract. So I just mentioned that, let's go back here. I just mentioned that the minting is generic. So let's say we didn't take a storage deposit. Let's say we didn't even have it. It wasn't even a payable function. And let's say we just get rid of all this. So let's say that the user just comes to my NFT contract and just mints, right? So this means that any user, provided they pay the gas burn, can mint an NFT. But the problem with that is that storage inside the smart contract, like the storage of the data structure. So for example, you have to store the token ID, the metadata string. That storage is rented by the smart contract itself. And what do we mean by rented? The user has to basically, well, not really the user, but the contract has to have enough near tokens to be locked up to basically rent the space, enough space for this token ID and this metadata string. So if we let a bunch of people just come to this contract and go NFT mint, and they mint thousands of NFTs, the contract eventually will run out of near to be able to lock to pay for storage. So that's why we measure the initial storage usage of the contract. So we get that from the environment variable here. So we call a function n storage usage. And then what we do is we figure out the new token size in bytes, the required storage size that we need. And then basically we calculate it. And then here we're depositing anything above the attached deposit that the user gave. So if the user attaches one near token to mint an NFT, you'll see that they get back most of their near tokens. So we're a good contract. We don't charge a fee. We just deposit anything that we do not need to cover that storage. So in this way, the smart contract can actually mint millions of NFTs and never run out of near, because we're always going to take this required storage in bytes from the user. The old standards, just getting back to that question, the old standards do not do this. So basically they don't do this for the NFT. They don't do it for the approving of accounts. So let me show you what that looks like really quick here, actually. So if we go to NFT Core and we look at where a user is going to approve an account ID. So what does that mean? That means the user has a token that they own, and inside each token, there is a list of account IDs, a list of, let's call them marketplaces, a list of marketplaces where this token is okay to be sold. What does it mean, like okay to be sold? It means that the marketplace is approved to transfer the token on behalf of the user. Now, what happens in each token that is owned by a user if you just keep approving marketplaces? So you go approve, 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 approve. What happens is you run out of contract storage. So basically, the smart contract could run out of contract storage because some user who has a token, accidentally decided to approve 1 million accounts. And that could be that could be a problem. And so in this way, what we do is we make the user pay for every single approval that they want to add to their tokens. And when they revoke the tokens, we give them a refund back. We transfer the storage released. So what you'll see if you look at the NFT simple contract, so again, it's a little hard to get to, but it's under core contracts. If you want to kind of sniff around and see what's being done before we sort of officially launch everything, you just go to the core contracts and go to NFT-simple, and you'll see that there's a bunch of updates here from just yesterday. So does that answer the question, Vadim? You think that's good enough?
Yes, thank you.
All right. Yeah. So just making sure everybody knows what we're doing with with all of these storage things flying around. Now, the question is, you might be asking yourself, well, I don't like this. I'm come from Ethereum and Ethereum's immutable and you pay once and it's burned into the blockchain. Why do I have to worry about locking up tokens for storage rental? Okay, so that's a really good point. The reason why Near works in this way, why contracts rent their storage, is it's not that the blockchain is somehow mutable. What it actually is that there's basically two types of storage kind of happening. So you definitely burn some tokens for storing the information, but then if you want to hold the information like in essentially a hot database, like what do we mean by like a hot database? Like a database where you can pull out the live information. So for example, if one contract wants to keep state inside of the contract and it wants to keep it live, then yes, you do need to pay to keep that state sort of live, so that with cross contract calls and with reading from the contract, like with a view call, you can pull that out really quickly. If you delete and release the storage, so if you completely wipe out an entry, so let's say I stored Vadim.near in my contract as the owner ID, but then I deleted it and I said there's no owner anymore. So for some reason I made it a none value or something in Rust. So what would happen is that the storage rent cost would go down for the contract, so you'd get some storage released. But then the question is it still on the blockchain? Was it still there? Well, yes, it was still there. It's on our archival nodes. So basically, if a node is set up to be an archival node, they still have a record that entry went in. It was there for a certain number of blocks, and then it was released. So that's kind of how that works. Basically, you have to pay storage rent for state that you want to continue to be active or live. I don't know. I don't have a word for this. Vadim, do you have any other way to describe this?
No, I think you said everything correct. And I think Ethereum 2.0 will have similar issues, or I don't know, questions, because also they will introduce something like that. Because otherwise, who will save the state for the lot of shards otherwise?
Yeah, that's
so
right.
So Near just going one step in front.
I think they are. Yeah, I think they are planning a storage. It's storage rent is what people call it. I guess in general. I don't know. Again, we're we're on the edge here. We're on like the bleeding edge of Near for NFT standard, but also just in general in the blockchain world. We're kind of right there on the edge. So anyway, so what does approving and revoking all of the approved account IDs do? Well, it's kind of hard to visualize any of this without understanding what the token is. So let's look at the token here. So for every token, we're going to have an owner, which is an account ID, metadata, which is a string, and approved account IDs, which is just this very lightweight hash set. So this is from our internal collections from our Rust SDK. So basically, the approve account ID, revoke account ID, revoke all is manipulating this hash set. So, and all you need to know is like, why do we have to keep track of storage? Why does it look a lot more complicated than just simply like a push or like an insert and a remove? Because it's tracking the storage usage. That's all. So each one of these functions has to be payable, and that's that. So now what I want to do is talk about the modifications. So I'll close these files. I put all the modifications that I made for the kitchen sink example, the sort of the NFT launcher example. I put all these modifications into lib.rs just to keep it simple. And what I'm doing is I just want to introduce this concept. So you may have seen like a previous video with the fungible token launcher where I show these apps where people can just show up at the app and say, and type in a username and say, I want to be a guest. I want to be vadim.matsnftapp.near. Okay, cool, right? So what I'm doing with the NFT launcher is I'm also adding that guest sort of logic in as well. Now, the trouble with these guests, these guest accounts, or some people call them virtual accounts because they don't exist on the Near blockchain yet, while they're currently sort of virtual sub accounts of the app account. The issue here is that they cannot send any Near tokens, but we would like the guest to be able to participate in the app. So we want them to use the app. We want them to be able to mint NFTs up to a certain amount, of course. We want them to be able to approve marketplaces where their NFT can be sold. And so what we have to do is we have to change some methods to account for this. So we have to take the payable methods. So let's just look at those really quick. We see that NFT transfer is payable, approve account ID is payable, revoke account ID is payable, and so is revoke all. And there's a lot of this storage stuff happening and a bunch of other stuff. So the question is, how does a guest account, who really is like a sponsored virtual account, like where all the gas fees are paid and everything, but they're still like a user in the contract. They're still a record. They're still a guest. They still can be an owner of a token, and they're still listed here as the tokens per owner, but they don't really exist on the Near blockchain. But as far as this contract is concerned, they exist. So how do we do this? So let's just take a look here. So this is just the initializing of the contract. So we're going to skip over that. And I put some more comments here in this non-fungible token launcher. So non-standard methods for guests and free mint / approval management. So we're going to actually let guests approve these tokens. So the first one is minting a token. Okay, so I decided like some arbitrary lengths here. I probably should make this like a const. So, let's just do that right now, actually. So we'll call it, guest. We'll just call it like guest string length limit. We'll make that, well, it's really arbitrary, but basically I'll tell you why I'm doing this in a second. Well, I mean, it's written right here in the comment. So let's tell you right now. So essentially, there are guests of the contract. So remember about the contract size. So we can't have the contract size explode, because what's going to happen is if everybody mints NFTs, but nobody puts any Near tokens into the contract size, the amount of data that it stores will get really large, and the contract will quickly run out of Near tokens to store the information, like to store the data. And in that case, the contract is locked, basically. Like it stops responding to function calls and stuff until somebody sends it Near, which is obviously a very bad situation to be in. So the contract owner needs to know how many guests they're going to add to the contract. And each time they add a guest, they probably should continue to top up their Near, right? So we could even make add guest a payable function, and we could add that. I haven't done that yet. But basically, each time you add a guest, you need to know what the maximum sort of damage, let's call it storage usage, the guest can use. So if we did not have a length, if we did not have a limit, token ID, by the way, is just a string. So up here, the type for token ID is just a string. So it could be like a IPFS hash or something. It's just a string. So if we don't impose a limit of 200, and again, this is arbitrary, 256 characters for the token ID and the metadata, what ends up happening is that guests might, put a giant, like they might put a whole JPEG inside your smart contract, which would not be very good. And if they do that enough times, they're going to lock up a bunch of near, right? So any questions on this? Like why we have to have a very fixed control over the guests' storage ability, like their ability to store stuff? Any questions?
It's clear. I just thought maybe we can create something like a maximum capacity of guests, which we are able to invite at the time. So not to overkill our contract storage. So,
right, yeah. Let's chat about that in a sec down at the add guest, remove guest. So let's talk about that's a good point though, because I mean, presumably we're the owner. We should know, but we should actually. I think it would be cool to take a deposit for each guest you want to add, just to make sure you have enough near. But again, like I'm not. I'll admit I'm not as gangster as Eugene. Eugene knows how to do all this like kind of storage stuff, and he probably has a way better way to do this. I just kind of did this quickly on my own just to make sure the example works. But basically, this is going to ensure that on a per guest basis, we don't go over a certain amount of storage. So we've limited the guest to token IDs and metadata. Then what we do is we call this helper function admin guest. So I use this in a number of areas. So I'm going to show you what admin guest is right now. So here is admin guest. What it does is it adds mints or it changes approvals. And what I do is I just make sure that we don't go over, whoops, this should be approval limit. I make sure we don't go outside of the bounds of the number of mints and the number of approvals. And then I just update it, and then I return the guest. Actually, wait, I just realized something I haven't done here. I haven't. I knew I was missing something because originally I had this. I had a signer ID here, and I wondered why I got rid of it. But it's because I have to update the. I have to update this here in just a sec. So we have to reinsert the mutable guest record here. Just a sec. It's guest. I think we're gonna have like maybe one of these clone issues or something like you borrowed it here, but you used it over there. Classic Rust stuff. Let me just see if this works. But basically we have to update the guest. Otherwise we would never have actually all of these calculations. If we didn't do this insert, all of these calculations would never have been saved. So let's, it's probably going to warn me that I borrowed or something. Always. Expected use size. Okay, let's check that in 1 sec. Oh yeah, I'll just change that variable and then just check what else is going on. Yeah. Okay, maybe we won't get the
your favorite error. Okay.
Borrow warning.
Yeah.
Okay. So this up here, just make it a U size. Doesn't matter. We're not trying to make the most efficient contract. Okay, looks like it should work. So that's good. Okay. So I think we're all good. So anyway, back to admin guest. So basically just check the limitations on a per guest basis, do all of the sort of what I would call the guest accounting work, and then update it, of course, which was the step that I was missing, and then return the guest. So each function that is a guest function can now simply once this sort of passes, well, actually, we should actually move this up here too. So we probably want to just assert that the arguments are valid first. And then what we'll do is we'll go get the guest, and then we update. So we add 1 to the number of mints that the guest has done. So they've done 1 mint so far. And then we get the we get the owner ID is going to be the guest account ID. And then we basically make our token. So we just create the token. And then we make sure that the token ID does not already exist. And, you know, if this is the insert operation at the same time. So it's kind of rolled into one, which is nice. So we make sure that this, this insert can happen based on this token. And if it doesn't have an exception, then it's basically going to insert the token. And then we, you know, increase the, well, we add the token to the owner, and then we increase the total supply. So yeah, so that's the NFT mint for the guest. And then the rest is pretty simple. It follows the same pattern. So go get the guest. And in this case, the guest admin stuff that we're doing is we're passing in, it was an option before. So we said that admin guest was none for the approvals. So we didn't want to update the approvals at all. But here we want to update the approvals. We want to add one. So we pass in one. When we revoke, we remove one. And if we revoke all, we want to set it to 0. So we pass in 0. It's not the best, by the way. It's totally my little hacky solution, but it helps me not have to write a bunch of code inside each method and like manipulate each thing one by one. So yeah.
Could you explain, please, why did you use this sum? What is it, sum?
Because I have sort of 4 situations. So change approvals is an option. So I have the situation that I don't want to change approvals at all. I have the situation where I want to revoke. This is revoke because I want to go down by 1. I have, I want to set it to 0. So that's revoke all. And then I have, I want to add an account as an approval. So I want to approve 1. So I have like 3 things I actually may want to do, and one situation where I don't want to do anything. So I made it an option, and I just say, if it's not there, then just return the guest and don't, oh, wait, you got to do this first. Otherwise you'll be minting on end. And then if you do that, yeah, if you do that there, you're okay. So I think that should all work. Does that help? I mean, again, it's not the best. It's probably not even the smartest way to do it, but it gets it done. Do you have a suggestion?
No. I just like curious why, if you put this sum as a parameter for the function, in this case, you can skip sending the value, right? Or you can skip sending the parameter at all.
Yeah, you can send a none value, but
just
then you
none.
have to
Okay.
You have to ask it. So under mint guest, you just send none.
Okay. Yeah,
and I mean, but you have to check, right? Because then later on in your method, it's expecting that something's there, right? So
okay.
Yeah, there's probably a better way to do this and a better way to kind of write this syntax, but like, you know, we're not worried about it too much. So let's get to, I haven't even done the upgrade guest part. So that's after your NFT is sold. So I probably, for this example, I may actually add a very, very, very basic marketplace contract, which is simply going to act like an automatic, it's kind of going to act like an automatic market maker. So it'll buy any NFT that you approve. So it's going to be a very, very simple contract. I'm going to preload it with Near, and then you're going to approve the market, and then you're going to tell the market to buy your own NFT kind of thing. So it's basically just going to allow the guests to sell their NFTs into an automatic NFT market maker and then basically get Near. So, but I'm going to do cross contract calls. So the example should get a little bit more exciting. So let's take a look at the app test though. We can put that back in actually. So there's a few different things happening here that I just want to explain. So let's look at the test utilities here. So when the contract is, when you run test deploy, you build a new contract and you deploy a new contract to a new dev account. So of course that contract is not initialized. So what you do is you call a init contract every time you run the app.test.js. You're going to call a init contract, and you're going to try to initialize the contract by calling new. And so you'll pass in the new arguments. Who is the owner? The owner of the NFT contract is going to be the contract account itself. So it's going to be the account that we deployed the contract to. So that's all that this is doing. The rest of these are all just helpers. So it's just, get account, get contract, things like that. It's not that important. What actually happens when you run all the tests is that I set up, Alice, Bob's ID, Bob, some metadata. So just whatever metadata we want, some token IDs. So I just make sure there's like some random token strings that we can sort of count on as being, unique or whatever. It's really messy. This was kind of done pretty fast, but basically those are the token IDs that I'm going to use. So I'll just pull from this token IDs array in each one of my tests. And then there's the contract ID and the guest ID. So the first thing that happens before all the tests is you initialize the contract. So, I just showed you that method. So we initialize the contract, and if it's already initialized, it'll just catch that error and continue. Then you always create, I always create a new user called Alice. And Alice is a user with actual near tokens. So in the config, the default new account amount is 5. So Alice will get 5 near tokens. Then you just log out her ID. Then this is where it gets interesting. So we're going to create a guest account for Bob. So what we have to do is we got to create Bob's guest account. So Bob is going to be a sub account. That's what this little period is here. A sub account of the contract ID. And the reason why is because, the contract has to maintain these usernames. And if Bob was going to upgrade to a real near account later, we need to know that no one else can steal the username. And basically only the contract itself can reserve these usernames. So while Bob is a virtual account, right? So Bob does not exist on the near blockchain for real. We're going to put Bob into the contract under this special guest account ID, like sub account, because only the contract owner can actually create accounts by that name. So that's why we choose that kind of way of doing it. And then we're going to log out that ID. The rest here is basically like make a key pair. So basically we're going to make a set of keys for Bob. So that's like what we would normally give Bob to be able to sign transactions for the account. And everyone who has a near account has at least, hopefully, one set of like a public private key pair. So anyway, that's for Bob. We get the public key, and then what we do is we have to get the what's called the guests account. And so for this, I kept the same account secret. So I just put that in the config. So normally that would be like maybe stored somewhere on your server. This is kind of like a little bit weird, but it's basically just for key management. So there's the contract, there's the guest account, and then there's the virtual accounts that we're creating. But the virtual accounts don't exist. Only the contract and the guest account exist. So what we have to do is we have to add Bob's key to the guest account, and then the guest account is the account that makes the contract transactions. But it uses Bob's key, so it makes the contract transactions on behalf of Bob. So let me actually, this is probably a good time to like draw a quick little diagram of this, because this is like a little weird. This is some other stuff. Okay. So basically we only have two real near account. We have guests, and we have, let's zoom in here a bit. We have guests, and we have, actually, I'll put guests here, and we have the contract account. So we have the contract. And what we do is we add these key pairs to the guests account. And actually, I'm going to put them as, I'll just put them as little squares. So they're in here. It's like key one. And I think you get where I'm going with this, but basically just want to really illustrate what's going on here. You know, this is going to, let's just get rid of that one. So basically you can have many guests inside the guests account, and they're just guests because their keys are added to the guests account. And then what you do is you put them into the contract, and they fall under, I can just show you in the code where it is. They fall under guests here. So it's a lookup map from public key to the guest struct here. And then what we have is under guest, we have the actual account ID that the user wants to be. But remember, that's not a real account ID. It's like a fake account ID. I mean, it's a virtual account ID. So this is where we have the account, you know. So Bob is guest. So G something something contract ID. And the public key here is Bob's public key. So Bob's public key, whenever there's a transaction made with Bob's public key, it maps to the Bob guest record. Whenever there's a transaction made, so that could go to Bob, and we could add another guest, and that guest could be Carol. Does that kind of make sense? Any questions?
No, I'm fine. That makes complete sense. Yes. Yeah.
Yeah. Right. Cool. And then these, by the way, these go to point to you know, tokens by account ID. So they all start to point. So what we do is we get the guest account ID. So we look up, well, we looked it up already. So we have Bob, right? And then just imagine Bob is that one that I wrote here. So it's something like that, right? So Bob is unique. Carol is unique. The point is that one key, one guest, one account ID, but the account ID is virtual. But that doesn't stop us from using that account ID, which is a valid account ID, inside this lookup map. So then what we do is we get something like this, where we have Bob, Carol, tokens by account ID, and then gets, you know, unique token, right? So unique tokens for each guest. So it ends up like that, basically, inside the contract. So yeah, so that just kind of explains all of that. And then we'll go back. So we have this guest account. Remember, the guest account is the contract, not Bob's account. So for the guest account, we want to add the key. So we add the key to the actual account, right? And then we add an allowance. So we say that this guest is going to be able to spend up to 0.1 near in gas, okay? And then we call the contract as an owner, we call the contract, and we add a guest record. So what does that look like? It's way down here. We add a guest record. So all we do is we insert into guests the public key as the lookup, and then the actual guest record with the desired account ID that the user wants. So the user wants some account ID. To be honest, there's something wrong here. It's not very safe. It should basically take whatever they pass in, because it's safer to do it on the blockchain. But basically it should be like, you know, let final account ID equal, and then you probably want to use like format. And then you do that, and you do whatever they passed in as like, actually here, you probably want to just change the names. You probably want to say username string. And then you probably want to pass in that and self.owner ID. So now there's no way that the user could pass in some bullshit username or steal an account ID from someone else. So that's probably better, to be honest. It's like more secure. So that's going to makes the virtual account ID. And it makes sure that before, the user could have just passed in any account ID and then their public key would have been a guest, but it could have looked up another account, right? So they could have potentially taken someone else's account. And plus you also have to check. Oh, well, no, they wouldn't have been able to do that because of this. Okay, little bit paranoid here, but yeah, I guess we can go back. We don't have to worry about that. So basically, they pass an account ID. We go make sure that the owner is the only one who can do this. Well, that's another good thing, that the owner can obviously check this account ID that they're creating. But basically, they're going to check tokens per owner, and you can only register a guest under an account ID that is not already taken. Because what I was worried about before, I kind of saw this, I kind of forgot about this. I was worried that somebody could put in a username of an existing account and steal their tokens, right? Like that would be bad. So basically that won't be able to happen yet, or that won't be able to happen. And you can't add a guest twice because of this. So cool. Okay, so let's go back to the tests really quick and let's get through the rest. So we go through, we create this guest account, and then the rest of this is, so you may see this in my code a lot. You'll see it in these app tests. You'll see it in server side tests. You'll see it in actual apps that I'm building. We probably should have like a helper function for this, but basically what it does is this connection variable here is the current instance of my connection to like the near blockchain. So when I go to like sign a transaction, so when I say like add a key or, call this contract function, right? Or call this contract method, right? Blah, 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 function call. So when I do anything, it's going to use this connection and it's going to ask the signer key store whether or not it has a key pair that can actually sign the transaction. So what I'm doing here is I'm saying that for the current network that I'm on, for the guest ID, so the guest account, remember in the drawing, Bob doesn't make transactions because Bob is not a near account. Bob makes transactions through the guest account. So for the guest account in the current flow of these tests, for the current guest account, it's going to be Bob's key that we're going to use. If we wanted to switch to a different guest, we would have to like make a new key pair. So we'd have to make like key pair 2, and we would switch to key pair 2 in order to be Carol. So if we make requests for this account on this network, so network, guest, so testnet, guest account, which key are we signing with? So testnet, this whole drawing, guest account, which key are we signing with? Is it Bob? Is it Carol? Is it Bob? Is it Carol? Right? So that's all I'm just explaining there. So you have to set this each time you want to act as a certain key, for a given account. So you want to like make this happen. So then Bob just, create a Bob account and that's it. So now we get into the good stuff. So NFT mint, NFT transfer to guest. So here's what's cool. Alice can mint a token and she can transfer it to a guest. So which is cool. So now what you can do is you can invite all your friends to your NFT game, right? And if you are already like a full account, like Alice, if you're already like a major player, you got near tokens, blah, 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 you can invite your friends, they can create a free account and you can drop NFT tokens to them. Okay. So that's cool. So drop NFTs or transfer NFTs to guests. Then we get into even more interesting stuff. NFT mint guest. So a guest can mint. and then NFT approve account ID as a guest. So this is where it starts to get really interesting. Guests can approve other accounts to transfer their minted NFT, the one that they minted for free. And then finally, the other account, in this case, I'm only using Alice. So there's no other like marketplace account. In this case, I'm only using Alice, and Alice is going to approve the, excuse me, Alice is going to approve, or sorry, she's not going to approve. She's going to transfer the NFT to herself. So Alice is like stealing the guest NFT, right? But what I'm going to do in the end is I'm going to actually build a market example where Bob or whatever will mint a free NFT, and then Bob will approve a marketplace. And then I think I'll just make Bob call the marketplace and say, okay, you know, sell my NFT. And then what the marketplace will do is the marketplace will go to Bob's account, transfer the NFT to itself, and then it will credit Bob. So it'll basically pay Bob a small amount of NEAR, and then Bob will use that NEAR to upgrade his account. All right. I know that was a lot. Okay. So let's actually call test deploy and make sure that everything kind of works. And let's talk about adding the marketplace. So what I would do here personally is that I would probably make a marketplace account that would be kind of like the guest account, and I would just make it, I'd call it market. And then every time I run a test, I like to make all the tests just like restart, you know, like from the beginning. So every time I run the test, I'd have to actually I have to add another contract here. So I have to have 2 contracts, and then I have to have 2 sets of WASM. And basically I would try to create the market contract, try to deploy the WASM to it, initialize the market, do a bunch of crap, and then basically, you know, go from there. So that would be sort of like the next step. So make a marketplace contract, produce WASM, deploy the WASM contract to the marketplace. I'll probably just end up doing it here. Just keep it simple. I don't know. But each time I do a test, well, I don't want to pay for the marketplace contract each time. So what I'll do is I'll just use like a fixed secret. And that's why I have this create or init account here. So basically, if the marketplace contract is already existing, then cool. If it doesn't exist yet, so I'll probably have to go back to here. So if the contract initialization happens, then what I'll do is I'll continue to deploy the market. So continue to deploy marketplace WASM. So I'll do something like that here. So basically, if I called test deploy, which I just did, I'll deploy a new NFT contract and a new marketplace. If I call yarn test, I won't deploy a new marketplace or a new NFT contract. Okay, so all the tests have passed so far. So yeah, so basically we were able to mint an NFT, transfer it to a guest who has no NEAR. And by the way, here's Bob. This is just for fun. So Alice actually exists. So Alice is a real account. So Alice exists, right? And you can see the transactions. You can see the NEAR balance. But if we grab Bob's guest ID, so this is the G something something ID, that doesn't exist. But what I thought was really fun or really kind of cool is that for some reason, our Explorer, our indexer, shows stuff like this. So it still shows that something happened. So I don't really know why, but it's kind of like a bug. But you can see that it wasn't created. There's no NEAR. It doesn't really exist. And if you actually put it up here, it just says not found, right? But anyway, last thing I wanted to mention, and then I'm going to kick it over to Vadim. Sorry, guys, it took a while, but I think it's good to go over all this stuff. So the last thing I'm going to mention is, okay, so if you look actually at the token, you see, so at some point there is an approved account ID in the token itself. Okay, so Alice was actually approved to transfer this token, and that's how Alice transferred the token. Alice went to Bob's account, basically. Well, Alice called the contract. She called NFT transfer. She put in the token that she wanted, which was the token that originally was minted by Bob. Then it was approved by Bob to be transferred by Alice. She called transfer, and eventually she had to put this here, enforce owner ID. So she has to say who she's transferring it from. So it should be Bob's token, and she wants it, and she's approved. So she took Bob's token, and originally the approved account ID was here, and then there's no approved account IDs in the new token. So the question is, who got the storage refund back for the approved account ID? So this is I'll make the answer short. So Bob minted the token. So Bob actually locked up some of the contract storage. And then Alice transferred the token on behalf of Bob. And what happens is in the transfer here, the contract tries to refund the storage for all of the approved account IDs. But what actually happens is a promise is created. The near is attempted to be transferred to Bob's account, but because Bob doesn't exist, the contract never transfers any near away to Bob. But remember, the contract paid for Bob's approval list in the first place. So basically we're back at square one, right? Like the contract is okay. No storage gained, no storage lost in terms of near. So anyway, that's all I got for today. That's it. So look for next week, where we will have a marketplace, we will have a front end, and we'll take I guess, Vadim, do you still have time? We'll switch screens now.
Yeah, sure.
Okay, so for about, maybe 10, 15 minutes, we'll switch screens, and we'll also have a server-side API for the NFTs. So I'm going to stop sharing. Hi guys.
Yeah.
Thanks for waiting.
Hey, it was interesting.
Dorian, you look like you're ready for a nap.
It's like you have like a series, like a soap movie.
I know it's
every episode. Yeah.
It's a lot of stuff. Like
you have to describe in the beginning what was done before, how we came to this point, because everything is connected. All subjects are global.
It's all about, I mean, at the end of the day, it's all about storage. And when I try to add the guest accounts I'm trying to add the guest accounts because it's important for me, and it's important for other people that users can come to a blockchain app and not have to have crypto, and not have to go through some faucet or some 14-step setup process. They can just use the app, make a mess, and if they create something valuable, that's great. If they don't create anything valuable, who cares, right? And the whole point is, let's just get people into crypto apps and having fun, right? So let's take a look at the server stuff. I'm excited.
Yeah. So like a little disclaimer, I think I wrote one line of code just 1 minute before the first call happened, 2 hours ago. And idea of the server came like 24 hours ago. So it's I will be very surprised if everything will be working right now. Oh yeah, but what was the idea?
I'm sorry, Vadim, that's not good enough. I demand a working NFT API.
yeah. I don't know.
I
just catch several bucks.
Actually, we got this request from an actual like a partner, somebody who's building on Near. So it's a very real world kind of example.
Yeah. So what was the demand? One company wants to transfer their existing application to the blockchain, and they want to see what will be the flow. How can they send tokens, mint NFT, send from one user to another, but they don't have enough time to build everything properly using the blockchain. And they asked us to help. And we spoke about maybe we can just make something like a wrapper, like a REST API, So they will just use existing and very simple and something what they already know, HTTP request to make all blockchain stuff. So proof concept that everything will be fast and all NFT on the back end, it makes normal blockchain calls like usual blockchain, like a real DApp. But for them, it will be just a HTTP request. And if everything will be fine, if they will have approval, then they can easily switch their code from HTTP requests to real blockchain calls. And we can even help them because we will use, I don't know, several methods and just replace them with real code. It will be quite simple. So what I did, I made using Happy, I made one gateway and I can show you here. I don't know, probably it will, maybe something will work. Okay, let's create a user. I will make a call Matt.
We can only see, just so you know, we can only see your browser.
Ah, really? Sorry about that.
And I'm just going to make one comment. Awesome, awesome intro. Just one additional comment. Vadim is using the exact same NFT simple core contract that I was showing you before. So a lot of the contract stuff has been covered. So we're now seeing it deployed and we're seeing the owner kind of administer all this stuff. Awesome intro.
Yeah, I used contract what you showed before. I deployed it somewhere in the blockchain. I think I called it nft.api.testnet. Sorry, NFT. So it's there. This is a contract of NFT. And this is my REST API. If you see, it's Insomnia, so it's normal REST API stuff. So, okay, Matt is already taken. I will call Dorian then.
Vadim, also, sorry, quick request. Could you just make this screen like a little bigger if possible? I don't know if it's easy.
Which one? This Insomnia one? Or...
Yeah, like the text.
I cannot do it. I don't know how to. Zoom in. Zoom in. Is it better?
Yeah, a couple more. Yeah, one more maybe. Yeah, just so it's a bit bigger for people.
It's not so beautiful now. So I click. I want to create. I am a game. Something happens, and we have new user in the game, Dorian, and we will call just a post request to server. We want to create a user. Okay, with Matt it was faster. Okay, Dorian is created. So it's real blockchain account, Dorian. I don't have this opportunity to create virtual account. So real Dorian account just happened 16 seconds ago, but we didn't actually, from our game server, nothing happens. We didn't create any master key, nothing, just we are use functionality from the application. Then we want to use, we want to mint NFT for our game. So it's, maybe we will do it before the Dorian came. So how will we call it? I don't know. Token ID. Okay, best token ever.
Golden Eye.
Okay.
That's actually, that's one of my favorite James Bond movies. Actually, GoldenEye, Casino Royale, they're some of my favorite new ones. Let's go. Vadim, favorite James Bond movie?
I already put. Well, yeah.
Dorian, go.
Yeah.
I haven't seen them before.
You haven't seen any James Bond movies?
Mm-mm.
That's
Nope.
it, Dorian. You're fired. No, I know it's corny, but I'm kind of like I have a guilty pleasure for James Bond. So did we create it?
Yes, we created. We minted one NFT, token ID 007, and
Nice.
the name GoldenEye. And
What happens?
we can check.
Try to mint it again. Does it error?
I can just prove that it was minted here. So we called it. We call that method here, and we called it. And because we have method view token, I can put this 007, send request, and we will see that our GoldenEye exists in blockchain, and this is the owner of our NFT. So it's not enough.
That's going to go to your server and then it's doing a view call. That's why it's really fast. It's just pulling the information from RPC and then just spitting it out, right?
Yep. So,
Cool.
but somebody minted that NFT before, maybe when they designed the game. But now Dorian registered, as we remember, and now we want to transfer token to him. So we will put this Dorian.api.testnet token ID 007, and our owner ID is API and memo. Okay. Welcome. Receiver ID is Dorian, right? So let's try.
And that's actually changing state. So it takes a bit longer, right? Because it has to go through a full.
Yeah, and this is testnet, so maybe real application will be faster. So yeah, it's transferred. Now we see that if we will switch now this view call to NFT to check this 007, I believe it will change the owner. So I click that request. So yeah, now it's new owner. And in the blockchain, we can see the same. So now our Dorian, where is he? Here, Dorian. So now it doesn't show here the call. Okay, so just he has this NFT in his account. And if we will create another one user, let's say Dorian2. Dorian2.
And now Dorian has to transfer to Dorian2, right?
Yes. Just I want to show that it's before when I started this demo, we didn't have any key from Dorian. It was created during the demo. But still, it will be fine. Now from Dorian, we will send this token to Dorian2.
By the way, Vadim, just so you know, I think you only have to include enforce owner ID and memo if it's a transfer from an approved account. So basically like a little bit more complicated like the marketplaces. I don't think for what I would call a simple transfer, like a peer-to-peer transfer, I don't think you need these two. But we can try it later.
Yeah, I use that field just to send, to show the contract who is the real owner now. From where shall I send? Yeah, maybe we can put it to different field, but I just kept this as it was in the contract.
It's good though. It's good to have. Yeah.
Yeah. So cool.
It'll show up. It'll show up in the transaction data too. So it's nice.
Yeah. So now Dorian sent token to Dorian2, and if we will update our state, it's now Dorian2. So what happens? One player registered in the game. He made some action. He got a token. Then he made another one action, and say for example, he lost his token and he sent his token to different player who overtake in some challenge this player. So, and in the end, we have real blockchain transfers, real NFT minting, real changing ownership of NFT, and our programmers from our game, what we said before, they didn't put any code of blockchain inside their demo. So they can use only these simple get post requests and play with blockchain calls and perform all this stuff, what they will need to do after demo will success and after they will have maybe funding, I don't know, or maybe when they will have time to finalize this decision. So, and I just want to remark that because we have a very small amount of methods here, it will be very simple for us to train developers how they will translate these HTTP codes to blockchain codes. Because if you want to see it's just a simple Node.js application. For example, what is minting NFT? We just have master account and call that function with token ID and with metadata and some parameters. How do we? I don't know what we do. How do we create account? The same. We just have some information about RPC. We call something. We get something. That's fine. So that was.
Can we go back to the Dorian account on the Explorer?
Yes.
Because we should see the function call there now, right?
Yeah. Cool.
Awesome.
He sent token to Dorian2.
Look at you go, Dorian.
Earning
NFTs, sending them to friends. friends named Dorian too. So let's not get too excited.
All my friends are just number additions to myself. So
All right.
Yeah.
So I think that's it for today. Thanks, Vadim. You know, thanks for being very your demo was so much shorter than mine. I mean, I'm trying to explain a bunch of the stuff that we're doing with NFTs, but yeah, it's good. This is really exciting. So I'm going to stop recording now. Thanks everybody for checking it out. This is, you know, live app review. We do it every Thursday. If you want to join and just be kind of like a silent, you know, audience member until we sort of do questions or something, like, you know, feel free to reach out to us on Discord. And if you're thinking about building on Near, or you want to partner, or you want a cool app to be like a sample app or something to be made, just like kind of what Vadim's working on, you know, give us a chat. And if we think that it's something that's useful for the, not just your app, but for the wider kind of Near developer community, something that we're missing, we will work on it, and we'll let you know. All right. See you later.
See you.